It's John Black, Super Chemist. We're here to make some ETHYLMAGNESIUM bromide, which is a grignard reagent. That's a reagent that you use in a grignard reaction. So before I can do the grignard reaction, I need a grignard reagent. Okay. You can react a grignard reagent with a lot of things. The easiest thing, at least in my mind, would be carbon dioxide. Although since it's a gas, maybe it's not that good. You know what I mean? Because you got to bubble it in, whereas a liquid you can put it in there and reflux it for a while. And, you know what I mean? It's not all escaping the reaction. But anyways, I'm using ethyl bromide that I made in a video. Got some magnesium and 2 diethyl ethers for every mole of these, right? I got my molar volume, molar mass of each thing. Now you can see this needs 2 moles, so I doubled the molar mass, and I got 208 milliliters. You got your, it's ionic. You got your ethyl magnesium on one side, your bromide on the other side. Anyways, I took these down. What I did was all these 208 and these ones I took and I divided them all by 3. Okay. And I got these numbers down here. Now I added in slightly more, an arbitrary amount. I just, because, make sure there's enough to react. Some of it will have too much of the oxide coating on it and it won't react, so I just threw in another 9/10 of a gram. Diethyl ether, it forms dative bonds with the ethyl bromide. So when you use this 208, or in this case 69.3, you need at least 2 for every one. So I threw in a little bit extra just to make sure, and as solvent, you know what I mean? You want some solvent in there. And my mistake was I jacked it up to 80 milliliters. That 11 milliliters or whatever it is, I was planning on putting that in the pot. Instead, I put it in with the ethyl bromide, and you'll see later that I made a mistake there. But anyways, let's get back to this. A dative bond is just a bond-formed bond. Like you have a covalent bond, that's where 2 atoms, each one donate an electron, and they share them equally, or somewhat equally. An ionic bond, that was a covalent. Now this is ionic bond, is the same thing. 2 atoms are sharing 2 electrons, right? Each one has an electron, but one is being greedy and pulling on or having control of the electrons more than the other one. That's ionic. Dative is they don't both donate an electron. Only one of the 2 atoms donates 2 electrons. In this case, it would be the oxygen always has 2 lone pairs there. That's what those 2 lone pairs are for. They're to form dative bonds. Oh, the experiment needs to be water-free because water doesn't react with a grignard, and so you'd lose all your grignard reagent. You know what I mean? If you put water in there, it'll react with that instead of the electrophile that we're going to use, which is carbon dioxide. So I baked all my glass apparatus in the oven. 250, 300 degrees Fahrenheit for an hour or 2 hours, whatever, an hour and a half. And I dried all my the ethyl bromide and the ethyl diethyl ether. Dried it down, molecular sieves and etc. You'll have to watch the videos if you want to see how. That's pretty much it. Let's get started with the experiment. First thing I want to do is go over my apparatus. It might be hard to see here because the background is, it's not just one color. But anyways, it's just basically this part right here. Okay, don't worry about that stuff over there. That's for later on. I'm going to put this set up like refluxing. See how I got my water condenser here. Up on top I have a drying tube, calcium chloride in, that's anhydrous, right? Down here I'm going to put my magnesium in. And then I have this separatory funnel, or equalizing funnel rather. I put my diethyl ether and my alkyl halide, which in this case is ethyl bromide. I'll put that in here, and I'm going to drip it in, and I'm going to, once it gets to 10% of my product being in the round bottom flask, I'm going to stop this. Okay, stop dripping it, unless the reaction starts by itself by then. If it starts by itself, I'll just keep dripping it in. If not, I'll have to stop and heat this up with my hand, or maybe a hot water bath. Alright, so let's get this started. I'm going to take the magnesium and I'm going to try and grind it up a little bit, just so I can scratch the surface to get the magnesium oxide off of it, so it'll be more reactive. Now, if it doesn't help enough, you can always throw a little piece of iodine in there, very small piece. Alright, let's start dripping this in. I got a cold water bath here, and I got a hot water bath too, just in case I need one or the other. There goes the first drip. Second drip. There we go. I got it covered. Put a little bit more in. That's about 10%. This has been chilled down, so it might take a while. Maybe hot water. Oh, starting to reflux it. Holy crap. Pull that down, maybe. It's definitely getting hot. I could see how this reaction would get out of hand, man. That was going up the condenser like all the way to the top, man. I started getting scared there. That's why I put the cold water on it. I don't know if it's working or not. It seems hotter than it should be, that's for sure. So I'm thinking that it is. I mean, I could barely touch this. This water, I could put my hand in this. No big deal. Yeah, it's definitely working. So I'm going to start dripping it slowly in, just to keep the reaction going, keep it refluxing like. Oh, Jesus. You can see, drip, drip, drip. Oh, it's definitely hot. Oh. I'm going to toss in another 20 milliliters or so of this diethyl ether. About 15 milliliters. I'll toss it right in the top. Just because I don't think there's enough in here. I think I boiled some of it away at the beginning there. Holy shit. Just trying to add it so it don't go crazy. You figure the diethyl ether boils at 30, what is it, 34.6 or something like that? So you don't want it to go too high above that, I'm guessing. Keep in mind, this is my first grignard. I've never done this. I'm not doing it from like any instructions or whatever, so. It's been about 20 minutes so far. It's staying hot by itself. I'm not heating it up or doing anything. I'm just dripping it in. That's producing the heat. Turned up the drip rate. It's been 30 minutes now. Now keep in mind, this room is 17 degrees, and this has been at 36 to 43 degrees for like 32 minutes now, or 30 minutes, or whatever it's been. So obviously something's happening. You know what I mean? Or wouldn't have went up that many degrees by itself and stayed there for a half hour now. I just keep adjusting the drip rate to keep the, you know, the more I drip it, the hotter it gets. The less I drip it, the, you know, so sometimes I'll stop it dripping. Most times it's just stopping by itself, so I gotta start it back up, which I'm doing right now. Now always remember, science is great.